If a force of 10 pounds is applied to the grip of the clamp, determine the compressive force F that the wood block exerts on the clamp. Alright, first thing, we've got a machine here, and the first thing we're going to want to do is we're going to explode it and break it into its component parts. Alright, now that we've exploded the machine into different components, let's identify the different reactions at each of the points. Alright, now we've drawn in the reactions at each of the points on the different members. Notice that here, member CD is a 2/4 member, so instead of the vertical and horizontal components at points C and D, we've just got the linear force that's collinear with the member FCD. And the first thing we want to do is we want to find the value of Bx right here. To do that, we look at the member BC here and take some of the moments about point C to be 0. So let's do that. C equals 0. And that implies that. And remember that there's a distance of 0.5 inches between points B and point C. So 0.5 inches times B of x minus, and between point C and the 10-pound force in that, we've got 4 inches. So we want to take 4 inches times 10 pounds equals 0. And we do the math, we get 0.5 bx is equal to, we move that to the other side, is equal to 40, and from that we get the value of b sub x equal to 80 pounds. Alright, now for our next step, you'll notice that we've combined members AB and AD into one member so that we can work with it more easily. Notice that the force F has gone away since we've got the force F acting here and acting here, it essentially cancels out. And since point A is now an internal part of this component, we no longer have to worry about AX and AY while we're working with it. So the next thing we want to do with this step is, again, we're taking moments, and we're taking the moments about point D to be 0. So we're doing another moment calculation. Moments about point D equal to 0. So what we want to do with that is got 2 inches to the 10-pound force. That will be in the positive direction at the moment. And this one is in the negative, so we're subtracting 2.5 inches to 80 pounds, which we found out to be our B sub x, and plus 0.75 inches times B sub y, since B sub y is what we're trying to find here. Okay, next we work this out somewhat. 2 times 10 comes out to be 20. 2.5 times 80 comes out to be 200. And minus 0.75 by is equal to 0. Move these to the other side. 0.75 by is equal to 180. And then we solve that out. And our by comes up to be 240 pounds. Now we're on to the last step. This time we're just looking at member AB here. Now that point A is no longer an internal point, we now have AX and AY again, and we've solved for BX and BY as 80 and 240 accordingly. Now to just find force F, all we have to do is again take moments, this time about point A, set it equal to 0. Moments about point A equal to 0. And that implies that 0.75 inches has distance between points A and B times 240 pounds, that's your value for By. And minus, because F is in the negative direction of the moment, 1.5 inches, distance between the point where force F is acting and point A, times F is equal to 0. Now we just need to solve for F. So, negative 1.5 F, we can multiply this out and move it to the other side. That's equal to negative 180. And then just divide negative 180 by negative 1.5, and our F is equal to 120 pounds. And that's how you solve problem 6108.